Good morning students. Welcome to the lecture 4 of Get DA Probability and Statistics series. So today we will learn these topics. What are those? Properties of union and intersections, complement of events, the De Morgan's law, the concept of subset, the axioms of probability, odds in favor and odds in against. And we will also solve some problems. So what are the properties of union and intersections? So union and intersections of two events follows commutative, associative and distributive properties. So topic 2 of today's lecture is complements of events. So what exactly complements of event is? We all know that event is always the subset of sample space. If E is an event and this is the entire sample space, that is S, then E complement is equal to 1 minus E. This portion is called E complement. So if I subtract the event from the sample space, then the left portion is called complement of E, or this is also written as like this. So complement of E consists of all the elements that are present in sample space but not present in event. So if I toss a coin, what is the probability of head complement? Probability of head complement is what? Probability of head complement is sample space minus head, or 1 minus head. Always remember, probability of sample space is always 1. So that's why probability of head complement is equal to probability of sample space minus probability of head. Complement of head, if this is head and this is tail, complement of head is always the entire sample space minus head. Entire sample space minus head is equal to complement of head. Now we will learn the topic number 3, De Morgan's law. So De Morgan's law simply states that A union B complement is equal to A complement intersection B complement, and A intersection B complement is equal to A complement union B complement. Now we will learn about the fourth topic, that is subset. If we have two events, event E and event F. Suppose this is event E and this is event F. If all elements of E is contained in F, then we can say E is contained in F, or E is subset of F. So this is the symbol of subset. The example of E subset F, or example of subset. If we throw a die, we know the sample space is 1, 2, 3, 4, 5 and 6. Here 1 is subset of sample space, 3 is subset of sample space, 2, 3, 4, 5, 6, everything is a subset of sample space. Now we will learn about axioms of probability. Probability of any event will always lie between 0 to 1. So this is the axiom 1 of probability. Probability of sample space is always 1. This is the axiom 2 of probability. For any sequence of mutually exclusive events where EI intersection EJ is equal to 0 or nothing in common for all I and J, here probability of E1 intersection E2 intersection E3, or probability is this of this sequence is equal to probability of every individual element in this sequence, probability of E2 plus probability of En. This can be also represented like this by applying formula of probability divided by mod of sample space. Here mod of every individual item divided by mod of sample space. So this is the axiom 3 of probability. So now we will solve a problem on the topics we have already learned. So the question is, a total of 40% Indian population uses GPay, 10% uses PhonePe and 5% uses both. That means intersection of GPay and PhonePe is 5%. So what percent of Indian neither use GPay nor use PhonePe? So what are the concepts that we will be using here? Here union, the concept of intersection and the concept of complements of events. These three concepts will be using for solving this problem. So pause the video and give it a try. So probability of GPay here is 0.4. 40% means 0.4. So here probability of PhonePe is equal to 0.1, 10%. Okay. 5% uses both. That means intersection of probability of intersection of GPay and PhonePe is equal to 0.05. 5% means 0.05. So what percent of Indian neither use GPay nor use PhonePe? Here at first we have to find what percent of Indian uses both. Then we have to subtract that from the sample space. So here probability of GPay union PhonePe is equal to mod of GPay plus mod of PhonePe minus mod of GPay intersection PhonePe. So we already know GPay intersection PhonePe is equal to 0.5, and we also know the mod of G and mod of P, that is 0.4 and 0.1. So directly put the values 0.4 plus 0.1 minus 0.05 here. So 45% of the people uses both, either GPay or PhonePe. Okay, so what is the population who doesn't use PhonePe and doesn't use GPay? That means we have to find complement of GPay union PhonePe. We have to find this. How we will find this? We all know complement of an event is equal to sample space minus that event. We already learned this. So just put the value in the formulas. So here probability of GPay union PhonePe complement is equal to 1 minus 0.45 is equal to 0.55. So 55% population neither use GPay nor use PhonePe. So now we will learn about odds in favor and odds in against of an events. So what is odds in favor? The ratio of favorable outcomes to the unfavorable outcomes of an event is known as odds in favor. So what does that exactly mean? Suppose here A is an event. So odds in favor of A is equal to mod of A divided by mod of A complement. That's it. This is the definition of or formula of odds in favor of a particular event. So odds in against of A is complement of A divided by A. That's it. Number of unfavorable outcomes divided by number of favorable outcomes. Let's solve two problems on odds in favor and odds in against. So here the question is, find the odds in favor and odds in against of throwing a die and getting a 6. Here we have to find the event and complement of event first. Here what is the event? If we throw a die, what is the probability of getting a 6? Here getting a 6 is an event. Getting a 6 is an event. So what is E complement? E complement is always sample space minus event. So here sample space is equal to mod of sample space is equal to 6. Here mod of event is equal to getting a 6 is 1 among them. So mod of E complement is equal to 6 minus 1 is equal to 5. So here mod of event is equal to 1 and mod of E complement is equal to 5. So probability of event is equal to mod of probability divided by mod of sample space, or 1 by 6, and probability of E complement is equal to mod of E complement divided by mod of sample space, that is nothing but 5 by 6. So here odds in favor is mod of E divided by mod of E complement, that is equal to 1 by 5, and odds in against of event E is equal to complement of E divided by mod of E is equal to 5 by 1. The second question is, odds in favor of India winning the World Cup is 4:3 and odds in against of New Zealand winning the World Cup is 2:6. Find the probability of India winning the cup and New Zealand winning the cup. So here event 1 is India and event 2 is New Zealand. What is saying here? Odds in favor of India winning. That means odds in favor of India is nothing but mod of I divided by mod of I complement. That is equal to 4 by 3. And what is given? Odds in against of New Zealand is nothing but mod of New Zealand complement divided by mod of New Zealand. That is given 2:6. So odds in favor of India is equal to mod of I divided by mod of I complement is equal to nothing but probability of I divided by 1 minus probability of I, that is equal to 4 by 3. So cross multiplication, 3 of probability of I is equal to 4 minus 4 of probability of I. Simple mathematics. So 7p of I is equal to 4, or probability of I is equal to 4 by 7. So odds in against of New Zealand is equal to complement of n mod divided by mod of n is equal to 1 minus probability of n divided by probability of n, that is given 2 by 6. It is 2 by 6. So here comes probability of n is equal to 4, probability of n is equal to 6, probability of n is equal to 6 by 4 or 3 by 2.